Hi, Algebra 2, welcome back. Here's the start of a new chapter. We have chapter 13 where we're going to focus on trigonometry. Okay, and so we're kind of moving away from this talk about functions. We're going to do a little bit of geometry. Okay, we're going to start here with 13.1a. We're going to use trigonometry with right triangles. Okay, so the focus for a lot of chapter 13 is going to be right triangles because they're nice. They behave nicely. They do nice things for us. We'll talk about non-right triangles towards the end, but right now we'll focus on the right ones. Okay. So our objectives are to review info about right triangles from geometry. You should kind of remember this stuff, but if you don't, kind of a little bit of a reminder. And then define the 6 trigonometric ratios. Okay, so we'll get to that towards the end. Let's first kind of start with, our right triangle. Okay, remember that a right triangle is a triangle that has a right angle. Okay, so we have something like this. Forgive my drawings, okay? So it has to have a right angle, and the right angle is always indicated by a better looking little box. If I can make it look pretty decent. There we go. I think that's as good as it's gonna get. So it's always, the right angle is always indicated by this little box, okay? And remember, a right angle is 90 degrees. So this is a right angle, and it's always 90 degrees, okay? And so that's all we need for a right triangle. And so we might kind of choose an angle. And so let's say that we choose this angle right here. Like I want to specifically talk about this angle, and I might call it theta. Okay. And so this is a Greek letter. So theta, that's how you kind of draw it. It's like a 0 with it has a little belt around it. Okay. So this is pronounced theta, and it's spelled like this. It's a Greek letter. Okay. And we're going to use that quite often to kind of mark angles on the triangle. Okay. So theta. And so based off of where I put theta, I like to label the triangle, label the sides based on where I put theta. Okay, so kind of I'll make a bigger triangle over here just to kind of have more room to write and talk about it. So I have my little right triangle here, and I can put theta wherever I want. Theta is kind of, you can think of it like x. It's just a variable. I can use it on any of these two angles. I don't really use it on the right angle. I could, but there's not really ever a point in doing that. So let's say I put theta here, okay? And so I have three different types of sides that I can talk about on the right triangle. The opposite side, the adjacent side, and the hypotenuse. Okay, hypotenuse. Hypotenuse. It's a nasty word. A nasty meaning. It's weird to pronounce and weird spelling, in my opinion. So, kind of what does that mean? Like, what does it mean for a side to be the opposite side, the adjacent side, and the hypotenuse? Well, the opposite side, it's called the opposite because it's across or opposite from theta. So across from, if I can spell, from theta. Okay, this is an R. That looks like a C, but it's an R. Okay, so across from theta. Adjacent means it's next to theta. Okay. These aren't really looking like thetas. I want to kind of redraw them. Sorry. There we go. There we go. That's a lot better. And then the hypotenuse, it's just the longest side. Okay, so if I label these sides using opposite, adjacent, hypotenuse based on these descriptions, then for this specific triangle, my opposite side would be here, and I'm going to abbreviate it OPP. My adjacent side, it's the one next to theta, so this one right here, adjacent, so ADJ. And then the longest side is this one, the hypotenuse, HYP. Okay, now it's a little confusing, this adjacent side description, because the hypotenuse is also technically next to theta, think about it as the side that's not the longest, right? The side that's next to theta but is not the longest, okay? Because that one is reserved for the hypotenuse, okay? So that's kind of the labeling for that. And understand that if I change where I put theta, for example, if I put theta here, if I instead kind of put it there, then this would no longer be the adjacent side, it would be the opposite side. And this would no longer be the opposite side, it would be the adjacent side. And then this would stay the hypotenuse, okay? Now, and that's kind of in a case by case basis. Once I put theta somewhere, I don't want to necessarily change it unless I want to work with a different angle, okay? In that case, we might need to do a little bit of relabeling, okay? So that's just kind of the general idea of that. And then just one more thing to remember, the sum of angles in any triangle, right? In a triangle, what does that have to be? It's 180 degrees, okay? Cool. So then now let's kind of move on to talk about the 6 trig ratios, okay? So where did these come from? What is the ratio? What's kind of going on here, right? So we get these 6 trig ratios from dividing two side lengths at a time, okay? My handwriting is not looking well today. There we go. Dividing 2 side lengths at a time, right? And 2 side lengths of a triangle right here. So dividing 2 side lengths of a triangle at a time. So what does that mean? Well, if you look at all the different sides of the triangle, I can divide them in lots of different combinations. I can do opposite over adjacent. I can do hypotenuse over adjacent, etc. Right? And so that's kind of where these 6 trig ratios come from. Ratios meaning we divide 2 numbers. Okay, and so what are those 6 ratios? We kind of have these words to describe them. Okay, so we have 6 of them. We have sine, S-I-N-E, cosine, tangent, okay, and then we have cosecant, secant, and cotangent. Okay, those are the 6 trig ratios. Those are the 6 combinations of side lengths, just named. So these are their official names, okay? And so now kind of what the idea is that I get them by taking, these are actually going to be functions of theta. Okay, so based on where I put theta, when I take these functions and plug in theta, then I get those ratios, okay? So here's how it kind of all relates, okay? And so I can actually abbreviate all of these, and you're gonna wanna make sure you link the abbreviations to them because we're gonna use the abbreviations a lot more. So this is abbreviated SIN, cosine is COS, tangent is TAN, cosecant is CSC, secant is SEC, and then cotangent is COT. Okay, so then now here are kind of the ratios linked to the sides of the triangles. So if I start with the sine of that angle theta, then its value is going to be the opposite side divided by the hypotenuse. Okay, so I can find the sine of theta by taking the opposite side divided by the hypotenuse. We're kind of defining a new types of functions here, okay? So if you're like, what's going on? These are brand new functions that we're learning about, even though at the beginning I kind of said we're taking a break from functions. I lied a little bit, I'm sorry, now that I think about it. Cosine of theta, that's gonna be the adjacent side divided by the hypotenuse. And then tangent of theta, I don't know why I'm spelling it out all the way. Tangent of theta is the opposite side divided by the adjacent side. Okay, this you can kind of remember if you've ever heard of the little acronym SOHCAHTOA. Okay, maybe you learned it in your geometry class, right? Sine is the opposite divided by the hypotenuse. Cosine is the adjacent divided by the hypotenuse. And then tangent is the opposite divided by the adjacent, right? It's kind of all linked. So, ka, toa, right? Kind of a nice way to remember it if you have trouble remembering it, okay? And so these, from these, we can actually get the other three, okay? The other three are kind of born from sine, cosine, tangent, okay? So kind of what I do to go from one to the other is we take reciprocals, okay? Cosecant of theta, CSC of theta, is defined as the reciprocal of sine. So it's actually equal to the hypotenuse divided by the opposite side. Secant of theta is the reciprocal of cosine. So it's the hypotenuse divided by the adjacent side. And then lastly, cotangent of theta is the reciprocal of tangent. So it's defined as the adjacent side divided by the opposite side. Okay. So those are our 6 trig ratios. You're gonna want to make sure you box this, highlight it, star it, put it on an index card, put it on the front cover of your notebook, because this is kind of what's gonna drive the rest of our section. We're gonna need to know all 6 of these, or at least be able to find them and know how to use them for the rest of this chapter, okay? Okay, and then one last thing, just as a reminder, the Pythagorean theorem, okay? Well, do you remember what the Pythagorean theorem says? It says if I have a squared plus b squared, that's going to equal c squared. What does that all mean? Like, what's the point of that? Like, what is that telling us? In a right triangle, a and b represent the legs, and c represents the hypotenuse, right? So a and b would be this leg, and then c is the hypotenuse. Okay, so if I square each of the leg lengths and then add them together, I get the same thing as squaring the hypotenuse. Okay, so this is a leg, this is a leg, and this is the hypotenuse. Okay, just to kind of, we're gonna need to use that for some of these problems coming up ahead. Cool, so let's use this information and see if we can make use of it, okay? So evaluate the 6 trig functions at the given angle, sorry, at the given angle in the right triangle below. Okay, evaluate the 6 trig functions at the given angle in the right triangle below. So here's our right triangle. Here's the given angle theta. So we're going to find sine, cosine, tangent, cosecant, secant, and cotangent of this theta right here. Okay, so before we do that, let's label our sides using the opposite adjacent hypotenuse, right? So if theta is here, then this means this side is the opposite side, and this side right here is the adjacent, and this side is the hypotenuse. Okay, before we can continue, remember that a lot of our trig functions, our trig ratios, use the hypotenuse, but we don't know the hypotenuse. So we need to figure that out first, and we can use the Pythagorean theorem to do that. Okay, so these two are our legs, so I can make this A and this B, or I can go the other way around. It doesn't matter, right? As long as they're both A or B, and the hypotenuse is our C. So I can do 5 squared plus 12 squared is equal to c squared, and I want to figure out what c is. So 5 squared is 25 plus 144 from 12 squared. So that means c squared is equal to, we add that up to get 169. Take the square root of both sides. Now when I square root both sides like this, I need a plus minus in front. So I get c equals. Since I'm just doing a shape here, I don't have any kind of coordinate plane placed on it. I'm not making this triangle kind of on the coordinate axis, which I will do later. Because of that, we're going to ignore the negative. We don't have any negative side lengths. We're just going to take the positive, and the square root of 169 is 13. Okay, so that's our hypotenuse length, c equals 13. Okay, so now we can find all of those trig functions, and it's not difficult at all. Sine theta, let's start there. That's opposite over hypotenuse from above. Okay, look back at your notes, or look up here actually. Opposite over hypotenuse. So I'm going to take 12 divided by 13. 12 divided by 13. And that's all you need to do. Okay, I just want you to tell me what value do we get from sine of theta, okay? And that's our answer. And we do the same thing with the rest. Cosine of theta, that's our adjacent over hypotenuse, so 5 divided by 13. Tangent theta, that's our opposite divided by adjacent, so 12 over 5, okay? And now I just have the other three left. I have cosecant of theta, secant of theta, and cotangent of theta. Okay, now we can be smart about this a little bit. If I just ask you to find these three, then you would have to manually do it. But I already found their reciprocals. So I can actually just take the reciprocal of each of these, right? As long as I have them lined up correctly. Sine is linked to cosecant, cosine is linked to secant, tangent is linked to cotangent, exactly the way I wrote it here, okay? And so it's kind of a nice strategic way to do it. So now I can just do, this one is 13 over 12, cosecant. Secant is 13 over 5. And then cotangent is 5 over 12. And there's your answer. Okay, here are our 6 trig ratios for that triangle. All right. These fractions don't mean much to us right now. It just seems like we're coming up with random numbers, right? And that's okay. These trig ratios are kind of useful, especially for more so for finding missing side lengths and missing angles. And we're going to do a lot of that in 13.1b. Okay, this is kind of just setting the foundation. All right, so now let's kind of finish off with one more example. Okay, if theta is an acute angle of a right triangle, and sine theta equals 4 over 7, what is the tangent of theta? Okay, so this first part right here, if theta is an acute angle of a right triangle, that just means kind of think of those and think of looking at that and think, okay, when I see that, I should draw a right triangle right off the bat. Okay, and so I'm gonna draw a right triangle a different way from what we've seen it so far, just so you can be aware that you're gonna see it drawn in lots of different ways. So here's our right triangle. And I'm going to put theta right here. Doesn't matter where you put it as long as you don't put it on the right angle, right? So there's my right triangle. Acute angle, remember that means an angle less than 90 degrees. In a right triangle, the other two angles are always going to be acute. That's a little bit redundant, but just kind of letting you know that's what you're going to see in a lot of the instructions, okay? And they give us an extra tidbit. They tell us that sine of theta, this theta right here, is 4 over 7. Okay, so we need to use this information, that's all we have, to find the tangent of theta. Okay, well, remember that sine theta is the opposite side divided by the hypotenuse. Oh, okay, so that means 4 is the opposite side and 7 is the hypotenuse. Okay, so let's label that first. Our opposite side would be this one right here, since it's across from theta. This would be our adjacent side, and this would be our hypotenuse. Okay, so we know that the opposite side is 4. So this side length is 4, and the hypotenuse is 7. Okay, so now we have a little bit more to go off of. Remember, our goal is to find tangent of theta. What is tangent of theta? Well, tangent of theta from above, that's the opposite over the adjacent. We know one of them. We know the opposite is 4. We don't know the adjacent. How can we find that? Using Pythagorean theorem. Okay, so I know that my 7 is my C because that's my hypotenuse, and C is always the hypotenuse. I can call 4 A or B. It doesn't matter. We'll just call it A for now. And so we're looking for B. So 4 squared plus B squared is equal to 7 squared. There's our equation. Let's go ahead and solve that. 16 plus B squared. Sorry, my 6's and my B's look really similar. 16 plus B squared equals 49. We need to subtract this 16 over. We get B squared is 33. Take the square root. Okay, these cancel out. Same idea here. It's plus minus technically, but we don't have any kind of coordinate plane here. It's just a shape. So we're going to take the positive. There's no nice square root of 33, and I can't simplify it either. So we're going to leave it as square root of 33. Okay, don't estimate it. Don't give me an estimation. Leave it in the square root unless up here I ask you to estimate or round your answer to blah, blah, blah. Because then that'll tell you, oh, okay, Mr. G wants decimals, not exact value. Okay, and I'll make that clear in the instructions. That way you know when to do that. Okay, so I found my B. It's square root of 33. If I found my B, that means I found my adjacent side. So I can finish the question. I know the tangent of theta now. I know it's 4 divided by square root of 33. And now we're done. Okay, and so this is a really good, this is going to be a common question you're going to get if I'm going to give you, okay, here's the right triangle and this is what you know so far. You know the sine of theta is this, or you know the cosine of theta is this, you know the cosecant of theta is this. And if you know that, I want you to find other trig functions based off of that one piece of information. Okay, so you get a question like that, and you'll get a question like this where I want you to find all 6 of them just given the triangle. Okay. All right. Hopefully that sounds good, y'all. I will see you in 13.1b. Have a good rest of your day.